food. So we try to manage those residues. But here, we will be speaking about the contaminants, which are not supposed to be present in the food. So unintentionally present or occurring in an unintentional way in the food. But some of them, this unintentional occurrence is always here. So we have to find a solution to manage it. So unavoidable, but we have several strategies to perform this management in order for us to protect the safety and the health of our consumer, but at the same time to ensure fair practices within the international trade. So that's our objective, right? And we will highlight these objectives in a very clear and structured way. The first part of my presentation will tackle the different management approaches or strategies for contaminants. And one of these management strategies would be the implementation of a maximum level, but it's not the only way of managing contaminants, right? So actually implementing a maximum level would be the last resort or way to manage our contaminants. Before that, we can have several management strategies that we could use in order to lower to the maximum possible the occurrence or the level of presence of those contaminants in our food, right? And then we will be discussing a practical example on some numerical data extracted from a previous working document that was discussed during the last CCCF session in Bangkok, Thailand. Very interesting example I selected for you, very typical. It was an evaluation performed by GFoRSS. And to reply, as Professor Sam mentioned, also to a question coming from CCCF, our manager, to GFoRSS, our assessor, regarding the suitability of implementing maximum level for mixtures of spices. So we will be discussing this in details. A very interesting application. But let's start first with these contaminants. And it is always interesting and important to define, to read again the word by word, the definition. So according to the Codex Alimentarius, and more particularly here we're speaking about the CCCF, the Codex Committee on Contaminants in Food, a contaminant is defined as any substance not intentionally added to food or feed for food-producing animals, right? So the non-intentionality of the presence is very important in this definition, which is present in such food or feed as a result of the production. So my production process could introduce a contaminant. And here I can stop and you can give me a lot of examples, right? So let's start one by one. A contaminant that is introduced into my food because of the production. Can someone give us an example? Because look at the list: production, manufacture, processing, preparation, treatment, packaging, packing, transport, holding. So for any one of those, let's try to discuss some examples, okay? Pick any of this list, any processing step from this list, and give us some examples. Professor Sam, you want to start?
Dioxin, so anything that may be introduced in feed, which actually is a production for animal-derived food, then that's introduced as part of the production.
Okay, that's one. Another example. If I say, let's go for a very specific situation, contaminants introduced through packing and packaging. What do you think?
Bisphenol A.
Any examples? Bisphenol A, BPA. So any migrating substance, packaging materials are not inert. And when we pack our food or we perform the packaging of our food, we could have some interaction between the packaging material itself, mostly plastic, paper and paperboard, even metals. And this interaction could release unintentionally or in an unintentional way contaminants, heavy metals, organic contaminants into my food. So they will be present into my food as contaminants, right? And BPA is a very typical example that was discussed during the last CCCF and will be discussed in the future meetings of the committee. Acrylamides, right? Produced during the preparation. of the food, toxins during transportation, storing, as Professor Sam gave you the example. So mycotoxins will be produced mostly during the inappropriate storage of the food under very high temperatures and in the humid conditions, right? So these are the contaminants that could be introduced. Now, if we check the list of contaminants that are regulated by and managed by CCCF, we will see mostly the family or category of heavy metals, right? So CCCF does a lot of heavy metals management: lead, cadmium, mercury, arsenic, and we will see also with Prof. Sam in a few the priority list of GFA, the latest updated version of the priority list of GFA, and we will see even new metals introduced for evaluation like thallium. Okay, so it's very interesting to follow up on this. Then we have the family of mycotoxins. So here you will see maximum levels in the general standard for contaminants and toxins in food and feed for mostly total aflatoxins, right? AFTs, total aflatoxins. We can find some maximum levels for aflatoxin B1, and we will find some maximum levels for ochratoxin A, OTA, and other mycotoxins, other phytotoxins that are regulated, radionuclides that figure in the list also of GFA, etc. So these are the major families of contaminants here. So the Codex definition of a contaminant implicitly includes naturally occurring mycotoxins and phycotoxins. So they are introduced, or they are naturally occurring, but their presence is enhanced due to inappropriate handling, storage of the food or of the crop. Now, let's start our discussion from the beginning. From normally, where do we start with this issue of a contaminant? Okay, what's the starting point? Normally, the starting point is that we have received some indications that a health hazard may be involved with consumption of food that is contaminated, right? So as a competent authority, as a risk manager, I'm receiving these feedbacks. I might have a problem after a consumption of a certain food, and it seems it is related to a certain contaminant. So I'm starting my investigation. I'm taking this from the starting point, okay? So normally that's my starting point. The next step would be, so I identified my hazard. I know that I have a hazard, but now I'm starting to think how I might manage this hazard, or how I might manage the risk coming from this hazard or the exposure to this hazard. So the ideal way is to start performing what we call an estimation of the total dietary exposure to this contaminant. What do we mean by the total dietary exposure? So Professor Sam explained the exposure thing. So the exposure thing is when we account for the occurrence of the contaminant, so the concentration of the contaminant in my food, expressed as a milligram per kilogram of food, microgram per kilogram of food, so the level of presence, combined with the consumption amount of this food. So how much I consume of this food per liters per day, grams per day, etc. Okay, so when I combine both, normally divided on a generic or an average body weight, I will have my dietary exposure to this contaminant through one food in particular. But if I'm just starting to investigate about a contaminant, I don't have a clear idea which food in particular is an important contributor to the exposure to this contaminant. So what I normally start doing is performing a total dietary exposure. So I will try to sample different kinds of food matrices that I suspect are contributing or participating to this exposure to this contaminant, and I will analyze them. I will have my occurrence level, then I have my consumption levels, and I will try to calculate to sum the total exposure to this contaminant. Okay, so then I will perform a risk characterization. So I will compare this total exposure to this contaminant to my health-based guidance values. Okay, for the case of contaminants, Professor Sam mentioned TDI, for example, a tolerable daily intake. Let's not forget, in the case of intentional added chemicals, we talk about normally TDI for contaminants, but when we have an intentionally added, we have as a health-based guidance value for pesticides, for additives. We have an ADI, right? What do we mean by ADI? So TDI, a tolerable daily intake. Yeah, or admissible daily intake or acceptable daily intake. Why? Because I'm intentionally adding these chemicals. Okay, so here I have a completely different toxicological profile. But in the case of contaminants, I could tolerate the presence of those contaminants. So I might have a TDI, and even for some very toxic contaminants, I even don't have a TDI. I cannot tolerate their presence. So they are not supposed to be here when I speak about lead, the case that we will be taking. So here, in order to compare and to perform our risk characterization, normally we do compare to what we call points of departures. PODs, point of departure, meaning the concentration starting from which I will start having a response, a toxicological response, okay? So I'm not even able of calling these a tolerable daily intake, but points of departures, for example. So let's go back to our total dietary exposure. So now I sampled what I'm suspecting food commodities or matrices contributing to the exposure to this contaminant. I combined my consumption data to my occurrence data. I sum up everything, and I have now a total dietary exposure, and I compare it to my toxicological thing, my health-based guidance value. And then I can answer this first question. Do I have a risk here out of the exposure to this contaminant? If no, there is no case here. If yes, I have to start thinking about managing this contaminant. And here, if yes, don't forget, I can access the profile of exposure. So I can know that this food matrix in particular is contributing the most to my exposure to this contaminant. And that's a very important information, right? Because for this particular food matrix, I would be thinking of setting a maximum level. Okay, are we linking how? So I'm taking the story from the early beginning of it. So how do we decide how CCCF as a manager or as a part of the risk management system of Codex with the Codex Sanitary Risk Commission is prioritizing setting maximum levels for particular food commodities? You have your answer? So these should be commodities that are important contributors to the intake or to the exposure to this contaminant. So now they are working on reviewing the maximum level for methyl mercury in tuna. Why methyl mercury in tuna? Because we know that tuna is an important food commodity that contributes to the overall intake or exposure to this contaminant. Okay, so it's not arbitrary. Like I have a request, let's work on a maximum level and set a maximum level for this food commodity because I want to do that. Great. Now, so identification of foods, food groups that contribute significantly to the total dietary exposure to the contaminant. That's one thing that we did now. But what we can also do and what we should investigate is also we should assess the impact of everything, the agricultural practices, the production practices on contaminant levels in food. So I'm starting to develop my complete dossier related to this contaminant. My exposures, the food commodities that contribute the most, but at the same time, how this contaminant is being introduced to my food through environmental pollution, during processing. So I need to have a lot of information here. So I start compiling this information. My production processes, the agricultural practices perhaps are introducing the contaminant, right? So that's the starting point. Then when I assess as a manager that I have a health concern, I will need now to have some risk management actions. What can I do? First, I will try to minimize the introduction of this contaminant from the starting point of it, which is logic, right? Instead of, I would not start thinking of setting a maximum level on the end product. Why not start managing the introduction, the point of entry of my contaminant from the starting point? It's more logic, right? So how I can do that? And besides maximum levels, so CCCF adopts provisions as maximum levels, but they have another very important standard they develop, which is when you connect to the page of CCCF, so you have the general standard of contaminants and toxins in food and feed. So here we have sampling plans, methods, maximum levels, etc. But if you look at the whole list of documents of standards, they are code of practices, right? So why? Because these contaminants are not supposed to be present. So I will need to implement some effort to minimize their introduction from the point of entry before trying to set a maximum level. So preventive control measures, prevention, isn't it the spirit of every food safety system? So let's try to preventive measures. So through codes of practices, preventing food and feed contamination at the source. So let's try to think about it. What can we implement? What can we improve in order to prevent the entry of this contaminant at the source? Applying appropriate practices in food and feed production and manufacture. As we said, a lot of contaminants are introduced through manufacturing steps and production steps. Let's try to optimize those manufacturing and production steps. Mycotoxins their production is exacerbated because of storage conditions. Let's try to improve those storage conditions. Okay, so that's my code of practice, and I will give you a practical example. So here, let's try to eliminate points of introduction. If we could eliminate our point of introduction, let's try to do that. For example, instead of planting the crop near an industrial area, let's forbid this. If you want to plant those crops or trees or etc., do it far from an industrialized area. Okay, if I have a part of my machinery containing lead and releasing lead into my food, let's forbid the use of this kind of machinery in order to stop the introduction of lead from the point of entry. That's very logical and practical, right? That's one. Now, I can work on the good manufacturing practices and the good production practices and good agricultural practices in order also to minimize the introduction of my contaminant. Then, which is a very specific case here, but always interesting, I have my contaminant and it's unavoidable. During my process, can I do something in order to decrease the level of this contaminant? For example, if I use higher temperatures in my processing, could it help me in decontaminating my food? But here, it's a very specific thing because it requires a lot of scientific knowledge about it and how to do it. Okay, but that could be one of the solutions. So I have it here, it's unavoidable, but through my processing, I could improve some extraction steps or increase the temperature that could minimize the occurrence of this contaminant. So that's also a solution. Look how many solutions we can have before setting a maximum level. That's a very interesting example of a code of practice that was adopted back in 2022 to look at the title, Code of Practice for the Prevention, so if we can prevent, or at least for the reduction of cadmium contamination in cocoa beans. That's a very typical situation, and CCCF worked on contaminants in cocoa beans, cocoa powder, chocolates for the past few sessions. So look, that's our AI friend that generated a recap from this document. And I will be mentioning some very technical and scientific information here, but just for you to know that when we have a code of practice, it's a very interesting and important piece of document. It encloses a lot and contains a lot of very important scientific information. It's not like just giving guidelines, generic guidelines, no. So look here. They are giving guidance before the planting of the cocoa trees before planting. You can start by doing some soil analysis in order to make sure that you do not have a high level of occurrence of your cadmium in your soil, because the source of my cadmium in my beans comes from the soil. Okay? Then you have to measure the pH of your soil, the levels of the organic matter of your soil, because all these parameters, chemical parameters of your soil, will contribute to what we call the bioavailability of the cadmium to be taken by the plant, by the tree. Okay, so that's one. Then your site selection away from roads or waste mining sites. Try also to work on the genetics of your species. Try to improve the genetics or the species of the tree that you are planting in order to select species that have low uptake. So try to select low uptake varieties. Then production to harvest. Soil and water testing. Do not irrigate with the contaminated water. Low cadmium fertilizers. Pay attention not to be using fertilizers that are introducing more cadmium to the soil. Sampling protocols. Avoid cadmium inputs. Now, soil cadmium immobilization. I have no choice. I have the cadmium in my soil. So what to do? I can chemically use my chemical information to immobilize the cadmium in my soil, to keep it blocked in the soil. How? I would change the pH of my soil. Okay, I will add components to my soil in order to modify the pH of the soil, what we call liming of the soil. I can add zinc to my soil. Why? Because zinc will be forming a certain complex structure with cadmium that will make cadmium not available for the plant, for the tree. So that's a lot of important scientific knowledge, right? So I invite you to go and check those code of practices. They are very important, and their implementation is very important. Not just to read them. Try to have a strategy to implement them at national levels, etc. Then we have guidance for the post-harvest practices, the transport, etc. So, okay, so you can go and check this code of practice adopted since recently in 2022, and it's very important. Okay, mostly for cocoa producing countries, but you have a full list of other code of practices. We're good? Okay, so that's already a very important step to manage the occurrence of my contaminant. Now, what's the principle of what is the basic management strategy or to manage the risk of contaminants in the food? It is what we call the ALARA principle. What is the ALARA principle? I will try to do everything in my capacity in order to make the presence of or the occurrence of this contaminant as low as reasonably achievable. Can I do otherwise? Do I have other options? It is here. It could occur in an unavoidable way. But at least what I could do, and the code of practice will do that, and the maximum levels will do that, is start to bring this concentration to as low as reasonably achievable. So let's always memorize this terminology. The ALARA principle is applied for the contaminants. So I will try to do as my maximum, everything I could do in order to minimize it, but to what? To the as low as reasonably achievable. Now, so we discussed already the first part through applying measures to prevent to minimize the points of entry. That was one. But a second options. Now, I wasn't able to prevent the introduction of this contaminant. I'm not a producing country. I import those commodities. Can I impose? I could. That's what the EU does, right? But I could impose on the producing country to have measures. But let's say I'm not in the position of imposing on the producers. At least I can control my imports, right? So I can apply measures to prevent contaminated feed or food to be marketed for consumption in my market. How can I do that? So what's the tool here in order to prevent the food from being introduced into my market? I will apply maximum levels, right? That's my tool. Okay. So what's now the advantages or the importance of using maximum levels? they will help me improve the predictability at my national level. Supposedly, if I'm enforcing and implementing a maximum level, I should not detect this contaminant in my market and my food commodities to concentrations above maximum level, right? I'm speaking in an optimal situation. I have the perfect enforcement and I'm preventing any contaminated food from entering to my market. But at least I'm improving the situation. Instead of, excuse me, not having anything, and I have food entering to my market with different levels and concentration. No, I'm controlling some of the food. So I'm improving the predictability at my national level. So at the least, if someone asks me, I would say that I have a well-enforced maximum level. So I suppose that the worst case scenario, the maximum occurrence level of this contaminant into my food would be the maximum level, right? So if my maximum level is 1 ppm, and I am enforcing this, supposedly, normally, all food commodities in my market maximum should have a concentration of this contaminant at 1 ppm. Otherwise, I would reject those food commodities from entering my market. So that's the predictability thing. And that's at a national level. Now, at an international level, if we do not have maximum levels, and thanks God we have Codex helping us in this. So I will be exporting, and then a country, an importing country, will be applying its own national maximum levels. Let's say it has a maximum level at 1 ppm. Another country, 0.5. A third country, 4 ppm. That's disturbance for the international trade, right? And what's the two objectives of Codex? First, to protect the consumer, but two, to facilitate the trade. So having this harmonized maximum levels will help us in removing unnecessary barriers to international trade. Okay, so are you convinced till now about the different management strategies for contaminants? I still have one management strategy I could apply. Let's say I'm not in so all my previous strategies didn't work. Okay, I cannot remove the points of entry. I cannot reduce the levels of my contaminant. I'm not able to enforce my maximum level. I don't have an efficient enforcement system. I could work on the second. You remember, I have the occurrence part. We've been working on the occurrence now, the concentration, but we're forgetting about the consumption part. Both contribute to the exposure, right? So the last solution is to work on the consumption part. I will give dietary advice. Please stop eating this. Or if you want to eat tuna, you want to eat sushi, try to limit your consumption to this amount per week. Isn't it interesting to manage my contaminant, the exposure of my contaminant? So I have my contaminant here. I have no other solution of managing its occurrence. So please limit your consumption, because consumption and occurrence will be constituting the exposure. Convinced? Okay, so that's from Health Canada, I guess. I extracted this, and it is a consumption advice. So specific advice on dietary recommendations may also have to be considered to complement other regulatory measures. And at the same time, we can complement. Okay, it's not one will be substituting the other strategy. We can complement. Okay, so look, thanks Health Canada for all these advices. Okay, so it is regarding mercury in fish. So we have a full page here, and we have a lot of interesting advices. Okay, that's good till now. So can we now dive in more in details related to the maximum level thing? Because that's what's interesting. But at least now you have the full idea. How do we manage the risk of contaminants in food? Now, those maximum levels for a contaminant in a food or feed commodity is the maximum concentration of that substance recommended by the Codex Alimentarius Commission. Here I'm taking the definition from the CCCF, to be legally permitted in that commodity. Okay? You can notice here the legal terms used to facilitate trade and to protect from a legal standpoint and point of view. But let's not forget that a contaminant should not be present in the food, okay? But it's unavoidable, so we're doing our best to manage it. So MLs are Codex risk management tools. So that's the management tool out of the different scenarios I presented for you. Codex uses two, mostly of them. Code of practices in order to minimize the entry of this contaminant, and maximum levels in case the entry of the contaminant is not easily manageable. Now, some principle, very interesting. All this information can be accessible in this generic standard for contaminants and toxins in food and feed. So, maximum levels do not need to be set for all foods that contain a contaminant or a toxin, right? I gave you the argument for this through our previous slides. We do not need to set the maximum level for all foods. It will complicate things. That's the example of the hammer and the mosquito Sam mentioned. We do not need to go for this, okay? So we will need to set maximum levels for which commodities in particular? The commodities that contribute the most to the exposure to this contaminant. MLs shall only be set for those foods in which the contaminant may be found in amounts that are significant for the total exposure. So now we understand. I started by presenting what is the total exposure, okay? And normally within CCC, of course, they have numbers. They have values for this. So normally they would consider a food commodity contributing to more than 10% to the total dietary exposure to this contaminant as with the merit of setting an ML for it, okay? So normally, if a food commodity, so I'm exposed to lead from honey, wheat, I don't know, okay? And then I realized that honey is contributing to more than 10% to my total exposure, so I will be setting a maximum level for honey, okay? Or also expect another reason. I'm receiving a lot of issues from the international scene. A lot of commodities are being rejected here, accepted here, rejected here. So I have a lot of problems in my international trade. That's a reason also to set an ML in order to harmonize. MLs should be set in such a way that the consumer, so two principles, that's CCCF. And please, let's not mix things. Here I'm speaking about contaminants only. And as you know, and now you're convinced that when we work with additives, it's another thing. When we work with pesticide residues, different risk assessment strategies. So here, ALARA principle, contaminants, I have to find a compromise between two aspects. Protecting the health of my consumer, at the same time, ensuring fair trade. Both at the same time. And if you're used to participate in the CCCF proceedings, you will notice that that's always the discussion. So, adequately protect the consumer health. MLs shall be based on sound scientific principles leading to ALARA levels, which are acceptable worldwide so that there is no unjustified barrier to international trade. And we will be relying on GFoRSS expertise in order to help us, okay? So GFoRSS does contaminants, additives, and residues of vet drugs. Pesticide residues, they have their own JMPR assessment. MLs shall only be set for those foods in which the contaminant may be found in amounts that are significant. That's what we were discussing. So above or equal to 10% of the tolerable intake, above or equal to or similar health hazard endpoint in one of the GEMS food consumption cluster diets. So let's speak a bit about, we spoke even, I think I presented during a side event last year, the GEMS food database for you, if I recall. So a GEMS food database, we will be speaking more about GEMS food database. So is the repository of occurrence data for chemicals that is used by GFoRSS in order to perform the assessment, right? So when we have a call for data, normally the data is submitted through GEMS food database, but we have other means of submission. You can send your Excel sheet to the electronic working group chair. You can send it to the ad hoc expert committee, an FAO or WHO. But what is preferred is to submit through this GEMS food database. So within the structure of the GEMS food database, we are submitting occurrence data, but WHO also has, we said we have occurrence and we have consumption. They have what they call cluster diets. They have 17 cluster diets, okay? They try to bring together countries that they think they have similar consumption habits. And they will ask for consumption data to be submitted or based according representative of each of those clusters. That's the way it is, okay? Then they have another food consumption database, which is an individual food consumption database. So here they will accept data from individual surveys. We'll be speaking a bit about that, but that's not the topic of our discussion today, not about consumption data, more about occurrence data. But just for you to know that, we have these cluster diets. They will do their calculations. They will do the exposure calculation using the consumption data from each of those cluster diets. If they find that for one or more of those cluster diets, you see, if in one of the GEMS food consumption cluster diets, so if they find that the exposure using the consumption coming from one of those cluster diets is showing that this food commodity is contributing to more than 10% in the exposure to this contaminant, so they will say we have to set an ML for this food commodity. Why I'm saying this? I'm saying this just for you to know that they will consider the specificities of each consumption habits. And they will say, if one of them, one cluster diet is exposed, we will do whatever we can in order to limit this exposure. Okay, so we will be setting a maximum level in order to protect even this cluster diet. Then they are going more strict here. If they find that we have two cluster diets and the exposure in these two cluster diets is contributing to more than 5%. So let's say I'm working on honey. I will take the consumption data for honey in cluster diet 1, cluster diet 2, cluster diet 3, etc. I will calculate my exposure to lead from honey in each of these cluster diets, because don't forget, honey is consumed in different amounts in every cluster diet. I have different consumption data. I have different occurrence data. Okay, and then I will calculate my exposure. I will compare it in my risk characterization step to my health-based guidance value, to my toxicological threshold. If I find that in one cluster diet, honey is contributing to more than 10% of the total exposure to lead, okay, I will say that I need to set a maximum level for lead in honey. Then, if I find that I have two cluster diets and honey is contributing to 5% or more in this total exposure to lead, 5% in this one and 5% in this one, I will say, okay, I will need to set the maximum level for it. Okay, so just to tell you that there is basis to take the decision when do we need to set the maximum level, but it is highly protective. I'm telling you that if contributing to more than 10% in one cluster diet out of 17, I will set the maximum level. Okay, etc. Now, let's go to the interesting part. We are GFA, and we want to set the maximum level. Okay, or you are members of an electronic working group, and this electronic working group has also the mandate of doing these calculations. When you check the documents of CCCF, some of them are generated by GFA, others are generated by the electronic working groups. I'm speaking about the calculations. And they do a lot of interesting work here. The document we will be discussing was GFA generated. Another one was generated by the electronic working group chaired by Brazil. So they do a lot of interesting calculations. So here, look at this stepwise procedure. So we need occurrence data. That's the first step. How do we gather occurrence data? We will have call for data. So you will be receiving a calls for data. And in a while, in a few, we will be having this discussion on the scopolitan situation, okay? Let's not forget that scopolitan is still listed on the priority list of GFA. Not evaluated yet, because we need data. Okay, so one, generate data. Provide this occurrence data through the GEMS food database or other channels. Now, GFA or the electronic working group will start by extracting this data. So let's take, for example, the situation of lead, the one we will be discussing, lead in spice mixtures. So they will go into the GEMS food database. They will launch a call for data first. Then they will go extract this data. They will have a data set, right? Concentrations of lead and spices mixtures. That's one. Two, they will start cleaning up, trying to check this data set. Do we have problems with the data submitted? Do we have outliers? We need to remove, exclude some data points from the data set. So they will go and do some statistical descriptive steps and analysis in order to clean, what we call it a clean up procedure. So they will be cleaning the data set. We will have a numerical example just in a few slides. Then they will start by doing some analysis. If you're used to studying the documents, the working documents of CCCF, you can see that in a lot of working documents presenting some results on maximum levels of contaminants, they will be doing some graphical representations, the levels according to regions, the geographical representation, according to years, the chronological evolution of the occurrence of this contaminant. So that's what we call the descriptive statistics. So they are doing some representations. Then they will do the most important part. They will calculate, they will evaluate the exposure, the dietary exposure. So again, in order for us to evaluate the dietary exposure, we have to combine occurrence levels with consumption data. Okay? That's one. That's one part of it. Exposure, I will be comparing this exposure to my health-based guidance value, TDI or point of departure in my situation. And I can here evaluate. So when I'm doing my risk characterization, so I'm checking if there is a risk for the consumer, for the health of the consumer. That's one part. Codex, protect the consumer health. Then I have another part, fair trade, that we will calculate what we call in this situation, in this context, the rejection rates. And that's a very important thing. The rejection rates of commodities in case they are circulating in the international trade and I am enforcing a certain hypothetical maximum level. Okay, so health of my consumer, rejection rates, together I will try to find a compromise in order to set my maximum level. Okay, can we have a numerical example and I will finish with this? Okay, let's try to do an exercise. And of course, then they will prepare a report. So the electronic working group will be reporting or GFA to the manager, the first management layer, CCCF, and then CCCF will send it back to the commission in order to take the appropriate decision. Okay, let's go. We talked a lot about these details. So let's have our exercise, our application. Okay, so for every slide, I will be having questions, so I'm waiting for answers. I talked a lot. Okay, so we explained all theoretical aspects. Now let's have a practical example. And normally during our workshop, we do this as a practical thing. But here we'll try to do it together following these slides. So we have this very interesting document. It was look, let's take it back. My manager, CCCF, so the member countries, had this question raised. We are set, you regulate spices, right? So for maximum levels, normally I have maximum levels for individual spices. True? Okay, you can tell me otherwise. Normally, CCCF has maximum levels for individual spices. Allspice, cinnamon, turmeric, okay? They had this question, but normally we do trade spices and consume them as mixtures, right? Right? A lot of spices are traded and consumed as mixture of spices. And here we have a big problem. The compositional information is inaccessible. When you come from competent authorities, you are the list managers here, so you should be facing this situation. I want to regulate this issue, but can I access the exact percentage of each individual spice in the mixture? Is it easy to access this information? What do you think? I have a mixture of 7 spices or 4 spices. Perhaps you may know which spice is the major component. But can you access exactly the composition? I have 12% in mass from this spice and 18% of this spice. Even the producer, perhaps, does not have this exact information. So this question was raised, and they said, okay, you're giving us maximum levels for individual components. In case I have a mixture, you're telling me that I need to account for what we call a weighted average of mLs. I will say it again. So I have individual mLs for every spice, but you are now the compliance verification body, and you have the result coming from your lab for a mixture of 5 spices. And in front of you, you have maximum level for 3 individual out of those 5. How do you verify the compliance of your mixture? What do you do? Any idea? Let's brainstorm it. Again, you have a spice mixture that was analyzed in my lab. I have one result coming to me, the level of lead. Okay? Now I want to verify the compliance, but I have maximum levels for individual components. So how you will be able to say it is compliant or not? What do you think? And it's a common situation, right? Because normally mLs are set for individual components. mLs are not set for end-to-end cooked, prepared products. You have mLs for wheat, maize, for individual crops, and then you might be brought to verify the compliance of a mixture. Okay, so normally we have this recommendation. It is mentioned in the CCCF documents. We need to know the exact composition of the mix. I need to know ingredient A, 30%, ingredient B, 30%, ingredient C, 40%. Then I can calculate a weighted average of my individual mLs, and I can apply it. Right? What do you think? Right, Professor Sam? So if I do not have this information of individual components, I cannot do that. Okay, perhaps I could apply an ML for if I know what's the major constituent component, I could apply the compliance verification to just the major ingredient. So that's why they had this question. Why not setting MLs for the mixtures? So I will have an ML for lead in between brackets, spice mixtures. It will facilitate our task, right? But it's not as easy as it is to do that. So as Sam presented, we are formulating our problem. Is it clear? The problem formulation, any questions? Done? So that's the problem formulation. Now, what to do? 1, compile occurrence data. The stepwise thing that we studied together, okay? So let's start. Look what they did. They went to the GEMS food database and they searched for occurrence values of lead in food commodities labeled as herbs, spices, and condiments. So that's the generic food group classification. Herbs, spices, and condiments. They found 14,805 data points for lead. It doesn't mean that now herbs, spices, and condiments is specifically a mix. No, it could be individual spice, individual herb, etc. So they did a clean up step. The second step, out of these 4,805, they were able to extract 5,250 data points reflecting generic food names, potentially describing spice mixtures, okay, due to the lack of specificity in the GEMS food naming system. So they highlighted a problem within the GEMS system. We do not have a food classification labeled as spices mixture. So they could advise CCCF and the CAC to add this, or WHO, sorry, GEMS is managed by WHO, to add this classification. And they excluded all other points. So they are doing their best, okay, in order to find occurrence level corresponding to spices mixtures. So they accepted, every evaluation assessment we do has limitations. So we always state those limitations, accept them, and move forward. Then, for this data set, for these 5,250, they made sure that they were covering a time frame of 10 years. So they were interested in going back to 10 years. Why? Because we had adopted a code of practice for lead. So they want to check if after the adoption of the COP for lead, I have a drop in the lead occurrence levels. So it is always interesting to go back for at least 5 or 10 years. I can compare. I have occurrence data coming from before the COP and occurrence data coming from after the COP. The COP had an impact or not? Okay, so they went back to 10 years. And as Sam mentioned also, they made sure that they had some acceptable level of geographical representativeness. So I want occurrence level for spice mixtures coming from Europe, coming from Africa, coming from India, coming from the Pacific, coming from Latin America, okay? They try to do their best. Look, that's the first set of data. Let's start looking at some numbers. That's the first table, okay? These are, sorry. I have my 5,250 data points, okay? They come from different food codes, the HS codes for the international trade. So, spices, roots, and results, herbs, spice, and condiments, NES. I will speak about this in the GEMS presentation, not elsewhere specified. So we have a very interesting food classification system. Herbs, spices, seeds, spices, fruits, and berries, okay? The 6 codes above, together, they constituted my data set, 5,250 data points. And then they performed, remember the stepwise, they started by doing some descriptive statistics, averages, percentiles. So non-detects, what do you mean by non-detects? Now I will start asking questions and not answering them, okay? So I need your answer. So what do we mean by non-detects? What is this data point classified as non-detects? I'm speaking about lead concentrations in spice mixtures. So what is the non-detect? Analytical chemists, what is the non-detect?
Below the limit of your
Below the method detection.
Absolutely. So I have the reported data points below the limit of detection of my method. These data points are very important. When you have data points showing non-detects, meaning in your lab, your control lab, you're analyzing spice mixtures, and you have 100 samples below the limit of detection. Report those samples. It doesn't mean that if I have 100 samples below LOD, that's not interesting to report and I will just report the high levels of occurrence. No, we need to have a representative view. Okay, so look here. We have even 71% of non-detects for the second group. So these are to be reported. And normally, I have strategies here within GFoRSS applied. I can replace them by 0, which we call it the lower bound scenario, or I can replace them by the value of the LOD, which I call the upper bound scenario, okay? But we're not diving into these details now. etc. So I have the 5th percentile, 50th percentile, mean, 75th percentile, 95th percentile, and 97.5 percentile. So what do we understand by the percentiles? Because these are very common things that we read in CCCF documents. In every document, you will be reading these. Okay. So what do we understand when we say in herds, the 95th percentile is the concentration of 1.31 milligram per kilogram. The 95th percentile. What do we mean by that? Okay, we have to mean that we have 5% of my data points which are above or below. What do you think? Which are above this value. Okay, so when I speak about the 95th percentile, average, you know what is an average, right? I have a collection of data points. I compute my average. Median is another way of having a certain representation. I'm speaking statistics here. Then percentiles. 95th percentile, meaning the value for which I have 5% of my data point above and 95% of my data point below.
I'm just gonna
Yeah.
try to interject here because I always had a problem with this because I hate the statistics in my studies. So essentially, when you have the data, you have your data and you kind of put the data and you spread it like here. Okay?
You want to use the board, Saf?
Just
Oh,
wanted to put it like this, So you have the data and you put it like that, and basically you try to move like from these data and moving up. So if you put like the way you have a distribution of the information, 95th percentile here. So anything beyond is above that. So basically 95% of the data is covered by whatever you have before. So that's what it is. It means 95% of the data is covered there. Only 5 is left out. Yes. So that's essentially how you try to capture it. And again, the way you decide on which one is more representative, that's also a policy decision.
Yeah.
On which one, where I consider to have things as a determining factor.
How much you want to be protective, right?
Yes.
That's a policy decision. And why we're mentioning the 95th percentile, now you will see why, okay? It's very important. Keep it in mind. The 95th percentile, meaning 5% of the data points are above this concentration. Thank you, Sam. So, and here they try to perform the calculations for 2 groups of consumers, right? I'm not speaking only about adults. I'm trying to protect children too. So they perform the calculations for children and for adults. What's the difference in my formula? So to calculate the exposure, again, exposure is occurrence times consumption divided by body weight. So the body weight will be changing between children and adults. Okay, so they took 20 kilograms as representative for children and 84 kilograms for adults. In order to do more calculations, they considered a mean consumption consumer and a high consumption situation, right? Because in a lot of instances, I have normal consumers, but I might have scenarios with high consumers of the commodity. So perhaps in country A, they will be adding half a spoon of the spice mixture. And another situation, they will be adding 4 spoons. It's a completely different scenario I have to account for. Okay, and these are, here I'm showing the mean consumption. So they consider that children will be exposed or consuming 3.8 grams per day of spice mixture, and adults 5.3 grams per day of spice mixture. That's the normal group. The higher consumption trend, 10.4 grams for children per day and 11 grams of spices mixture per day. That's here I'm speaking about consumption, right? Then putting these 2 together, we'll not do I will show you the results here. We're not doing the calculations. But before so out of these consumption occurrence, I can calculate my exposure, right? So that's one part. I still need another information, the rejection rate. for the trade, okay? How do we calculate the rejection rate? We set hypothetical MLs. Let's consider that if I apply an ML of 1 milligram per kilogram for lead, and these hypothetical MLs, normally we take them out of my percentiles. So my hypothetical MLs would be my 95th percentile, my 97.5 percentile, my 93 percentile. So I take the highest percentiles. Why I take the highest percentiles? Otherwise, I will be rejecting 50% of my commodities, my traded commodities. Okay? So I cannot. I need to have my commodity available. As Sam also said, I need to eat. Okay? So I cannot reject. And then I will make sure that this level does not pose any harm for the health of my consumer. That's the reasoning. So we have here two situations, hypothetical MLs. What if I consider I implement an ML of 2 milligram per kilogram or an ML of 1 milligram per kilogram? Lead and spice mixture, don't forget. We did the rejection rates. I calculated how many data points would be rejected if I apply the ML of 2. What do I mean by this? I'm applying an ML of 2. Any data point above 2 will be rejected. Any data beyond the data point below 2 will be accepted. So we calculated the rejection rates. For no ML, of course, I'm not rejecting anything. So are you convinced that having an ML is better than not having an ML, right? If I have a problem. Because if I don't have an ML, I will be accepting everything. So for countries that do not have the capacity of generating their own provisions, it's very important for them to push towards having MLs, having maximum residue limits. It will help them. So the least it will help them, okay? It's much better than not having an ML. An ML of 2 milligram, we calculated the rejection rates. We have about 2% of the commodities rejected if I enforce an ML of 2. If I am enforcing a lower ML, I will be rejecting more, right? I'm more protective. I will be rejecting more. So the rejection rate went to around 5.1%. This is a very clear situation. And other situations in CCCF, they had rejection rates going up to 18%, 20%. Okay, so critical situations. We cannot enforce an ML where we are rejecting 30% of the international traded stream. So that's my rejection rate. Then I calculated my exposures. And I'm doing my risk characterization step. What is here my risk characterization step? I'm checking when I apply an ML of 2 or when I apply an ML of 1, how much I am reducing the contribution of mixtures of spices to the exposure for or to lead. Again, when I'm applying a maximum level of 2 or a maximum level of 1, how much I am reducing or contributing to the reduction of the exposure to lead through the consumption of spice mixtures. That's my objective, right? Why am I implementing MLs? I want to reduce the contribution of spice mixtures to the overall intake of lead. So look, if I will be enforcing an ML of 2 or an ML of 1, spices mixtures will be contributing to which percentage out of my POD? You remember? My point of departure. Or in another situation, my TDI, my tolerable daily intake, my health-based guidance value, my hazard characterization thing. Okay? So if I don't have an ML. Again, I'm not rejecting anything. I'm consuming everything. And I'm exposing my consumers, or spice mixtures are contributing to 19% out of the value of my POD. Okay, so again, my POD is my threshold value. I should never go above it. Otherwise, I will have a toxicological response. Let's not forget, I'm exposed to lead through several food commodities, right? And here I'm speaking about just one of them, which is consumed to a very low amounts. I'm speaking about spices mixtures. I'm consuming them maximum, we saw 10 grams per day. Other commodities, I might consume them up to half a kilo per day. So this very low consumption, if I don't have an ML, is contributing to already building up to my threshold 20%. That's a huge, right? So what I'm leaving for the contribution of other foods, if through spice mixture, I'm at 20%, and I will be having lead even from environmental pollution. It will be compiling, and I will be going above this threshold easily. So I can never accept that. Do you remember our limit was 10% or 5%? I could never accept 20%. So the first conclusion, I need to set an ML. Then, if I apply 2 milligram per kilogram, I'm removing some high 5% thing, right? I'm rejecting the high levels of occurrence. So my contribution to this exposure is now reduced. So spice mixtures are contributing now up to 7% of this building up towards my threshold value. Okay, my POD, which is already good. But if I go to an ML of 1, now, sorry, I'm speaking French now. So I will be contributing to 5% of my POD, right? 5%. If I take this situation alone, protecting the consumer, which ML you will be picking? Which one? If I want to protect more my consumer, which one? 1 or 2? 1, right? I want to protect more my consumer. If I'm taking this situation alone, but are we supposed to build our management decision just based on this? No. That's one part of it, and I have the trade part, the second. Okay, so, and we have the values for children, adults, average consumer, high consumer, okay? We have all the scenarios. Every time you apply a lower ML, I'm improving the protection of my consumer, but I'm increasing the rejection rate of my commodities. Now, let's take a final decision together. We are discussing this in CCCF, and you are the member countries, and I'm the chairperson of the session, and we have to agree which ML you will be accepting. I will remind you about what we have. We are discussing no ML, ML2, ML1 milligram per kilogram. My rejection rates, when I go down, are going up from 2.9% to 5.1%. I'm rejecting more, but I'm protecting my consumers, whether children or adults, more. So I'm going down from, and look at the situation between adults and children. For the adults, we do not have an issue. Even with no ML, my percentage is 3% out of the POD. So it's not an issue here. The issue we are discussing is for children, and that's a very common issue discussed in the situation of lead. Because lead, the toxicological endpoint, impacts the IQ of children. Okay? So it's a very serious thing now we are discussing in our CCCF meeting, right? So let's take the proper decision. So again, let's take the situation of children. No ML, 20% of my POD, ML2 going down to 7%, and ML1 going down to 5%. So from 2 to 1, I'm just improving 2%. Rejection rates, I'm going up from 2.9% to 5.1%. And here I have to give you one more information for your consideration. CCCF agreed that they can never accept rejection rates above 5%. But that's a very critical discussion here, because 5%, 5.1%, is it above 5%? Okay, so I will leave the discussion for the final. That's the end of my presentation. So the conclusion. What do you decide? ML of 2 or 1, and why? And we have to listen. Yeah, from every table. Yeah. Will you accept a 2 or 1 and 1? Or you think that 2 or 1. 2 or 1 is okay for you.
Basically, you're making a weight in going from 2 to 1. From a health standpoint, you're gaining 2% reduction. From a rejection standpoint, you're practically doubling. Okay? Which
So,
one are you
yes.
going? I mean, I almost gave the answer, but you know,
you are the managers.
I gained 2% in protection, and I almost doubled the rejection on trade.
So 1 or 2.
And again, you know, if you are in another jurisdiction, you may say, you know what? Yeah, so be it. I want to reject.
I want to reject. That's my policy decision. Yeah.
You are in an attempt where you wanna support trade. You don't want to impact economies as much. So yeah. You don't want to waste food, etc. So, and remember, the principle is ALARA. So and I'm sorry here, interjecting.
No, please.
You know, I
please.
So,
Mike.
Yeah, please have the mic at least. Okay.
Well, stop it.
No. I don't need this to be recorded.
Oh, okay.
Yes.
Out of it.
No, I mean, in the word ALARA, there is the as reasonably achievable. And that reasonable notion is actually completely policy decided. So you decide what is reasonable. If a jurisdiction can consider that reasonable is, yeah, I want to get that 2%. And if it gets me, if I reject more, so be it. Okay? But that jurisdiction probably has established that as an acceptable level of protection that has been ongoing for, like, it's a policy that they have been applying all along. Now we are in Codex. In Codex, the balance of the two, your answer is 2 or 1. ML of 2 or ML of 1?
ML of 2.
ML of 2, because ML of 2 will still reduce exposure, so it will help us. And you know, like, the reduction is still, you know, significant in what it does, but at the same time, you are not rejecting so much. You just have 2% of the rejection, and you hope that with the code of practice, that rejection rate will go even lower. Okay, so because basically people will your data will indicate that you don't have that much that exceeds those values. Okay.
But I didn't understand that bit of that Codex that not accept 5.5 above.
A policy decision.
Having 5.1 already, we have to cut that.
No. It's the idea is the 5% rejection rate is basically it's a discussion amongst the committee that if I establish an ML that leads to 5% over, that ML is not suitable. But I cannot basically contribute to a 5% rejection rate. By the way, at some point we consider 10%.
Exactly. So then you decide.
The value has evolved.
Yeah.
So historically, we even consider 10%.
So it's a case-by-case situation.
Yeah, it is.
And do you consider 5.5 above 5? So we're not speaking about the numbers here. We're taking a management decision. Yeah.
Reading at the data and the committee making a decision using those two elements.
Thank you for the coming today. I just got a clarification on how this data analysis is done, particularly to our consumption. Because prices, it's not that much as we've seen for children and adults. I was wondering if we could have an exercise, you know, where we the region of familiar with food that we take a lot, that we could see this content is also
of course.
Have an exercise.
Yeah, that's the part we didn't tackle here, the consumption part. So we have scientific built methodologies. So we speak about what we call food frequency questionnaire, a 24-hour recall. So we have methodologies, scientific methodologies, in order to compile, and we do not do that for one commodity. We try to have a full the full consumption diet, or the consumption data related to the consumption diet of the population. So we have questionnaires, what we call food frequency questionnaires, 24-hour recall questionnaires, a combination of both, etc., in order to know how much you consume wheat, bread, meat, chicken. That's yours. Yeah, now you're on yours.
I'm on in any case. Well, I'm going to try to do the rest as quickly as possible because I think there's only one left, right? Oh no, but you have the demonstration. So okay. You know, just want maybe to to follow up on the question related to consumption data. So in what was presented so far, and in the way essentially GFA does the assessments, they have to use consumption data that is documented globally. And what is relied upon is what we call those clusters. Amin showed the clusters, and in fact, Amin, I don't know if you can go back to even the clusters, the slide where you have the clusters, because I was actually curious to see how countries of the region were dispersed into different clusters, So and I was expecting a question from you, how do the clusters or how are the clusters set? Okay, so sorry, I kind of okay. Basically, the clusters are set. The consumption data that is done using the cluster diet information is basically based on FAO collected data using the food balance sheets. So essentially, and food balance sheets are not necessarily consumption data. It's basically food availability. So it's not really what is consumed, it's what is available. So, and these are approximations. So essentially, the information is shown by gram per person per day. And then after that, what they try to do is they try to see the contribution of each group of commodities to the consumption. So essentially, wheat and wheat products will be part of cereals, milk and milk products will be in dairy, etc. And what they do is they try to quantify the amount of food availability for each food groups. Then they study countries with statistical distribution and looking at statistical similarities of the way these values are found for different countries. Countries that are closer together in this statistical distribution are put in the same cluster. So that's why sometimes countries can move clusters if you update the information. Okay, so right now, I think you are in G14, a number of countries. So Fiji, yes, you have, so I think G14, you have Fiji Islands, Kiribati, Papua New Guinea, Solomon Islands are there. But also I saw Samoa in another group, G17 maybe, right? So yeah, Samoa, you see, and Samoa is with Sao Tome and Principe. You see, one in Africa and the other one in the Southwest Pacific. So it's not actually geographic location. It's really the statistical treatment of the data. Okay, and that statistical treatment can change. Well, not the statistical treatment. The statistical treatment remains the same. But if you update the food balance sheets and you update the contribution of the different foods to the overall diet, you will have some changes, and you basically can change your clusters. Okay.